Welcome to online PGC classes. Today we will discuss about the Vaucheria. Vaucheria belongs from the xanthophyta, which is the division of the algae. So here is the structure of the Vaucheria, which is the branched filament in which the both reproductive organs, antheridium and oogonium, is present. So here is the occurrence of the Vaucheria. Vaucheria present as the freshwater alga, such as in streams, springs, waterfalls, and in damp soils. The Vaucheria plant body is found. And what is the plant body? Plant body is the terrace-like, which consists of the sparingly branched cylindrical filament. The filament is not septate multinucleated structure. Septa are produced only during the production of the reproductive structures. So here is the Vaucheria filament body, which is consisted on the branched filament on which the asexual spores such as the zoospores and the oogonium and antheridium is produced as the reproductive body. And here is the single portion of the filament which showing the internal composition, such as the many nucleated, and the food is in the form of the oil drops. Centrally located vacuole is present, and also the cell wall is the outer covering of the plant body, and also the chloroplast in which the photosynthetic pigments are present, and also the vacuole membrane is called the tonoplast, is also located internally. So here is the difference between a portion of the filament and the filament showing rhizoids and the reproductive structures of the Vaucheria plant body. First of all, we discuss about the haptone. So haptone, what is the haptone? Haptone is the rhizoid and the root-like portion at the lowermost portion of the filament. So these are the attachment point of the body and attach the plant body to any substratum. Next is the cell wall. The cell wall is the thin and consists of the cellulose and the pectin material. Next is the vacuole. Vacuole is in the form of the tubular filament which contains a large central vacuole filled with the cell sap. Next is the chloroplast. The chloroplast in Vaucheria is a small discoid shaped structure without pyrenoids. Reserve food material. Reserve food material is in the form of the oil drops, starch produced only if the plant is continuously illuminated with light. So next topic is the reproduction in Vaucheria. Next reproduction in Vaucheria is reproduces by the three methods: the vegetative reproduction, the asexual reproduction, and the sexual reproduction. The vegetative mean of reproduction take place by the fragmentation. The filaments are broken accidentally into fragments, each of which develops into a new filament. However, this mode of reproduction is not common. Next is the asexual reproduction through the zoospores and the aplanospores. Zoospores, a single compound multiflagellated zoospore, is produced in a club-shaped zoosporangium, which is cut off from the ends of the erect aerial branch. Aerial branches, the end of the filament becomes swollen and a large number of the nuclei and chloroplast aggregate here, and this part is then cut off from the rest of the filament by a portion of the septum. The central vacuole decreased in size and the nuclei arrange themselves at the periphery of the opposite each nucleus. These compound structures may be regarded as a group of biflagellated zoospores which have failed to separate. The center of the zoospores is occupied by a central vacuole. So this is the zoosporangium at which the zoospores are produced as a vegetative and asexual reproduction of the Vaucheria. These are the aplanospores The terrestrial species produces thin-walled aplanospores under dry conditions. These are formed in aplanosporangia, produced at the ends of the short lateral or terminal branches. The entire protoplast of the aplanosporangium is converted into a single rounded aplanospores. The aplanospores is liberated by a rupture in the wall of the aplanosporangium and develops into a new thallus on the germination. Here is the reproductive structure of the Vaucheria, in which the sexual reproduction is distinctly oogamous and the different species may either be monoecious and dioecious. The sex organs are antheridia and oogonia. Here is the antheridia, which is a hook-like structure, and oogonia, somewhat the bulbing structure of the Vaucheria plant body, is called the oogonia. The oogonia of larger size may be sessile or stalked and produce on the main filament or on the special reproductive branches. And this is the antheridium. A mature antheridium is usually stalked, tubular, often hook-shaped structure that develops before the start of the development of the oogonium in most of the species. Its name, the species, is the protandrous. The male organ mature first. It develops close to the oogonia. The branch bearing the antheridium becomes densely packed with nuclei and few chloroplasts. Therefore, the antheridium is often colorless. Later on, this branch is cut off from the rest of the thallus. A transverse septum is formed. The contents of the antheridium divides into uninucleate fragments, which then undergoes into the oogonium structure of the Vaucheria plant body. The flagella are unequal in size, laterally inserted and pointed in opposite direction. The smaller one is of tinsel and the larger one is of the whiplash type. Next is the oogonium. The oogonium development starts near the antheridium with a bulging in the main filament. A large mass of the colorless cytoplasm called wanderplasm, followed by many nuclei and chloroplasts, move into this bulge. The bulge increases in size and becomes an oogonium. The oogonium is separated from the main filament by the formation of a transverse septum. The entire protoplast metamorphoses into a single septum called the receptive spot develops. The apex of this beak gelatinize and form apical pore through which the anthrozoids can enter the oogonium. The sex organs mature almost at the same time. One of the liberated anthrozoids enters the oogonium through the pore formed at the receptive spot and near the female nucleus. The male nucleus increases in size up to the size of the female nucleus and then fuses with it to form a zygote. The zygote secretes a thick wall around it to become an oospore. The oospore undergoes a period of rest for some months before germination. On germination, it produces a new filament directly. The meiosis occurs at the time of the germination of the oospore, indicating that the adult plant is haploid. This is the reproductive cycles, in which the asexual cycle is continued through the process of the zoospores and aplanospores in the asexual cycle, while the sexual cycle, the antheridium and oogonium formation take place. After the fertilization, the zygote is formed. Zygote produces the oospore by the formation of the thick covering around the zygote. Then upon germination, the oospore goes the meiosis division and meiosis produces the haploid plant, the haploid filament plant, which is the Vaucheria plant body, and the cycle continues by this process. So this is all about the reproductive cycles of the Vaucheria plant body. Thank you. That's all.